Alright guys, I'm about to show you a bunch of examples for multiplying and dividing radical expressions, which you need to complete your homework and because you do have a quiz this Friday. So here we go. Radical 4 times radical 25. I'm going to go through a bunch really quick, okay? So if you feel like you need to, you can pause it and then just watch it again. Radical 4 times radical 25. Basically, the rule when you're multiplying radical expressions is, do they have the same index? If they do, then you can just multiply. If they don't have the same index, you can't combine them at all. These two have the same index, right? These are both square roots. The index here is 2, even though we didn't write it. So what you do is multiply the 4 and the 25, which is 100. And keep them under the same radical with the same index. So it's still square root of 100. And then the square root of 100, or radical of 100, is just 10. We only want the positive, right? We're only showing the positive in both of these. Okay? Let's do another one. That's your final answer for that one. How about this one? We have the cube root of 45 times the cube root of 75. The steps are the same. Multiply the two numbers underneath the radical. So what I have is 45 times 75, whatever that is. It's going to be a pretty big number. It doesn't matter what it is though. You can just go ahead and start simplifying right here. Now, this is not a square root, this is a cube root, okay? So in order to simplify the cube root, you're going to have to take out triples instead of pairs. What I mean by that is this. You factor the 45 using a factor tree. That's 9 and 5, that's done. 3 and 3, okay? You factor the 75 using a factor tree. That's 5 and 15, and that's 3 and 5. So what you have inside of this radical symbol is 1, 2, 3 threes and 1, 2, 3 fives. And now instead of looking for pairs like we usually do for square roots, we're looking for triples. We're looking for sets of 3. Okay? You see a set of 3 of the same type, circle it. There's 3 threes and 3 fives. And now to finish simplifying, just check how many groups of 3's are there. Only one group of 3's, right? So you're going to write 1 3 outside. How many groups of 5's are there? One group also, so you're going to leave a 5 outside. That's it. There's nothing left inside because you have groups of 3. You have perfect groups of 3. So your final answer is 15. All right, let's try one more. What if they have variables in them? Let's look at this one. The square root of 36x to the third. That's it, no multiplication, just the square root of 36x to the third. Steps are the same. Since this is just square root, it's a lot simpler. The square root of 36 is just 6. But what I have is x to the third, which, if you break it down, it's x times x times x, right? So you're looking for pairs, because this is square root, even though we don't write the index there, it's a 2. There's a pair of x's there. That means that one of those x's will make it out. Basically, there's only one group of x's. And then that single x is going to stay inside of the radical. And that's your final answer for that one. All right, keep going. Let's do some more. Let's try this one. I have negative 16 x to the 12, and I want the cube root of that, not the square root, the cube root. I'm going to break it down the same way that I broke down that other one over there, okay? 16, if you break it down, is 2, wait a minute, it's 2 and 8, sorry. 2 and 8, 8 is 2 and 8, 8 is 2 and 4, and 4 is 2 and 2. So 16 is 2 times 2 times 2 times 2. One of them must be negative though, or 3 of them must be negative, okay? So since it's negative 16, what I could do is turn 3 of them negative and leave the last one positive. Does that make negative 16? Yeah, right? 2 times 2 times 2 times 2 is 16, and negative times negative times negative will give you the negative 16 that you want. Why did I do that? Because I want a group of 3, and if I have this group of 3 right here, I could pull that number out. Okay, so There's a group of 3. Oh, I forgot the x's. How many x's are there? 12 of them. I really don't want to write all of them, but let's write them. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 3 negative 2's. There's also 3 x's, 3 x's, 3 x's, 3 x's. Okay, so what we have at the end is 1 negative 2 that makes it outside, because there's only one group of negative 2's. 1, 2, 3, 4 groups of x's. That means x to the 4th. And inside of the radical is just a single 2. Cube root of 2. The cube root stays, okay? Don't erase the index. That's it. That's your final answer. All right, let's try another one. I want to give you guys as many examples as possible so that you can do this on your own. Here, let's try number 5. The cube root of 216 x to the 4th y to the 3rd. The cube root of 216 x to the 4th y to the 3rd. I'm going to do the same thing. I'm going to break down 216. 216 is a perfect cube, but in case you can't see it, let's break it down. I think it's divisible by 2. 108 times. And 108, you can divide it by 2 again, which is 54. And 54 is 2 times 27. And 27 is 9 times 3. And 9 is 3 times 3. There it is. That's my factor tree there. Okay. So what I have is the cube root of 1, 2, 3 2's and 3 3's. And then 4 x's and 3 y's. That's what I have. And again, we're looking for triples. We're looking for sets of 3. Here's a set of 3 2's, a set of 3 3's, a set of 3 x's, and a set of 3 y's. And now we break them out. One group of 2's, so there's a 2 outside. One group of 3's, so there's a 3 outside. One group of x's, so there's an x outside. And one group of y's, so there's a y outside. A single x will stay inside, and it's a cube root. Okay, remember, it's a cube root. Don't forget that. If you leave it as square root, your answer is now very, very wrong. All right, let's try a couple more. Let's try this one. Multiply and simplify. Now I'm going to skip that one. I think you guys can handle that one now. Let's try this one here. 12x squared y times 3xy to the 4th. So we're multiplying two radical expressions. When you multiply, you got to make sure that they have the same index. These two have the same index. They're both square roots. If, for example, this was a cube root, I couldn't do anything here. There's nothing to do here because that's a cube root, that's a square root. I can't combine them. But since they are both square roots, we can do it. Okay, multiply them. 12 times 3 is 36. X squared and x make x cubed. Y and y to the 4th make y to the 5th. That's what you have. And now, just like the last ones, you just need to simplify that. Okay, so let's break it down. I know 36, the square root of 36 is 6. I don't have to break that down. X cubed and y to the 5th, though. So let me write it expanded form so that you guys can see. 36 is 6 times 6. X cubed is x, x, x. And y to the 5th is y, 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 y. 2 6's, 2 x's, 2 y's, 2 y's. I'm looking for pairs because this is square root. So what I have at the end is a 6, group of x's, 1x, 2 groups of y. That means that you take out 2 y's, y squared. And inside of the radical, what you have left is x and y. And that's it. That's your final answer for that one. Okay, let's try some divisions once real quick. I'm going to erase all this right now so that we can do some division problems. Here we go. Let's try this one. Division problem number 1. radical 6x over radical 3x. What you need to remember for division is that the rules are the same. You can only combine these if they have the same index, if they're both square roots, or they're both cube roots, or they're both 4 roots, and so on. Okay? These are both square roots, so we can put them together. What you can do is put them both under the same radical like that. And then you can simplify this part and then see what else you can do. 6x over 3x, well 6 divided by 3 is just 2. And x will cancel, so all you have is radical 2. And you're done. Let's try another one. Let's say I have a square root of 2x squared over the square root of 5x squared. So, same idea, right? Square root over square root, so I can just combine them together. So I have the square root of 2x squared, which, you know what? I'm going to go ahead and expand that. 2x squared is 4x squared, right? 2 squared x squared over 5 squared x squared, which is 25x squared. And now you can break it down. If you're looking for the square root of both of those, the square root of 4 is 2. The square root of x squared is x. Or you know what? We can actually cancel the x squareds first. Look at that. And all I have is 4 over 25. That's much simpler. The square root of 4 is 2, and the square root of 25 is 5. There. I found the square root of both of them, so it's 2 over 5. All right, let's try another one. This will be the last one. Okay. I have the 4th root of 2x over the 4th root of 3x squared. Okay. So I'm going to try to do the same thing. Put them together under the same radical. The 4th root of 2x over 3x squared. Try to simplify this. X cancels one of those x's, not everything, but one of them. So what I have is the 4th root of 2 over 3x. All right, that is not simplified. Okay, we cannot have a fraction inside of a radical. Okay, one of the main rules of simplifying radicals is no radicals in the denominator, in a denominator, and no denominators in a radical. Denominators. No radicals in a denominator, no denominators in a radical. No denominators in a radical, that's this. There's a denominator inside of a radical. That basically means there's no fractions in a radical. Okay? No radicals in a denominator means this. There's a radical in the denominator. That would not be simplified. Okay? That's not simplified. That's not simplified because there's a radical in the denominator. This one's violating this rule. No denominators in a radical. So what I'm going to do to try to get rid of that is break it up again and write it as radical, the 4th root of 2 over the 4th root of 3x. 4th root of 2 over the 4th root of 3x. Okay? Now, how are we going to make it so that there is no radical in the denominator? Now it's violating the first rule. There's a radical in the denominator. What you are going to do is you're going to multiply by something that equals 1. Okay? Something that equals 1 so that you can get rid of this radical. Okay? Now let's try something. This one's going to take me a while so you could, to explain it. But let's try a lot of different things. Okay? If I had, for example, radical 2 over radical 3. Let's start with the simple one before we get to that one. If I had radical 2 over radical 3, and I want to simplify this, what I would do is I would multiply by radical 3 over radical 3. And you're asking why? Why would you multiply by that? Why? Because if I multiply radical 3 times radical 3 in the denominator, what do I get? I get radical 9. And radical 9 is a perfect square, so that would be just 3, and the radical would be gone. So if I take this and multiply it by itself, I end up with just 3. Okay? In the top, I would have radical 6, right? Radical 6, which cannot be simplified. So that would be my final answer. This is the same as this. They're the exact same thing, they're equivalent, except this one is simplified because there is no radical in the denominator. Okay? Let's show you one more before we get to that one. What if it was radical 5x over radical 3? Radical 5 over radical 3x, like that. Then I would multiply by radical 3x over radical 3x. I'm basically multiplying by the same thing as there is in the denominator. Okay, radical 3x over radical 3x. Now when I multiply by radical 3x over radical 3x, I'm going to get radical 15x, right, over radical 3x times radical 3x. It's going to be radical 9x squared, which I can simplify because 9 is a perfect square and that's a perfect square. So it's radical 15x over 3x. And it's simplified. All right, what if it wasn't radical 5 over radical 3x? What if it was the cube root of 5 over the cube root of 3x? Like that. Cube root of 5 over the cube root of 3x. Then what I would do is multiply by another cube root. Okay. And see what happens. Look, I'm going to try to multiply by the cube root of 3x. If I follow the same pattern, that's what I would do, right? But look what happens. I'm going to get the cube root of 15x. And on the denominator, I'm going to get the cube root of 9x squared. Now you look at that. Can this be simplified the same way that the other ones were simplified? And your answer is no, because this is 9, which is 3 times 3. And x is x times x. But I'm looking for triples. I'm looking for 3 of a kind, so that's not enough to simplify. So what must I do still to get it to be simplified? What you need to do is multiply times another cube root of 3x. Why times another one? Because that way I have 3. And when I have 3 of them, I can actually cancel the cube root. Okay? So your final answer here would be 9x squared times 5, 45x squared. Cube root of that, of course. Cube root of 45x squared over 3 times 3 times 3 is 27. X times x times x is x cubed. Cube root of 27x squared. X cubed, I mean. And 27 is a perfect cube. So I can take the cube root of it, which is 3. X cubed, take the cube root of it, is just x. And that's your final answer for that. Okay, so these get a little bit more complicated, but it's okay, we can do it. Now let's finish that one. What must I multiply by so that I can get rid of this denominator, 4th root of 3x? You need to multiply by, you got to multiply by the 4th root of 3x. The 4th root of 3x. But multiplying times the 4th root of 3x once is not going to be enough, because you need 4 sets of that in order to get rid of it. So I'm going to have to do it again and again. That's what we need to do to get rid of this radical in the denominator. Okay, so let's go ahead and finish this up. It's going to be 2 times 3 times 3 times 3. That's going to be 27 times 2, 54. X to the 3rd, x times x times x. The 4th root of that. Over 3 times 3 times 3 times 3, which is 81. X times x times x times x, which is x to the 4th. The 4th root of that. And now I can finally simplify this, because the 4th root of 81 is 3. If you think about it, 3 times 3 times 3 is 81. And the 4th root of x to the 4th is x. There is your final answer with no radicals in the denominator. Okay? hopefully that's enough examples for you guys. You can try the rest on your own, and you can rewind and rewatch any of the examples that I did.